Hi, my name is Jorge Lucas Cortez, and I'm coursing for a career in engineering in mechatronics, and I'm here to present my PIA, resolving a problem about the derivative with reason of change. So for starters, we have to do the first step. It is read the problem twice. So I'm going to read the problem. It states if a cubic container if in a cubic container water fills up at a rate of 0.69 cubic meters per minute, then with how much velocity will the water level ascend if the base is 6 meters times 6 meters? Once more, if in a cubic container water fills up at a rate of 0.69 cubic meters per minute, then with how much velocity will the water level ascend if the base is 6 meters times 6 meters? Okay, and following we have to then identify and separate the information we're given, or the data, and that is obviously being asked. So we're going to do exactly that. We have our reason of change, which is the velocity according to the time, is 0.69 cubic meters per minute, and we're being asked the velocity which of the rate with the water level will rise up. And we are also given information that the base 6 meters times 6 meters. Next step, the third step, we have to draw a representative illustration of the given data, only if possible. We have it here. We have the cubic container, the water filling up. We ask the velocity of the water rising level, and here are the measurements of the length of the cube, of the base of the cube. Next, we have to find a function or an equation or a formula which relates the given information, the data we have. We also, lastly, when we have everything set up, we have to identify which data varies and which data stays constant. So obviously, we're trying to find the volume of the cube. So the formula, which states that is the area of the base times the height of the cube, of the figure we're calculating. Obviously, the formula for area of the base goes to length times length. We already have it stated there. Is 6 meters times 6 meters, giving us 36 meters squared. So then we do the substitute the value 36 meters squared. In parentheses, so we separate. This is the measurement, not any kind of variable. So there we have it. So that's the formula we're having. So obviously this is the constant that we're having. It's the only value we have. Is the length will never change, and the ones that varies are obviously the ones that are changing according to time. So this is our variable. Lastly, we have to derive or find the derivative of the equation according to the time, which is what normally is needed to do this corresponding isolation in order to answer the question. And this is our final step. So I will doing that nextly. Have to find the derivative according to the time in both sides. We want to isolate the value we're searching for, which is this one. So we change it to we pass per se the 36 to the other side. This is obviously, and we substitute the value we already have. We have the derivative of v here, 0.69 meters cubic meters minute over 360 meters squared. Obviously, they will make an equation and the division. I'm sorry. We can find our answer is 0.0191 meters per minute. That is subtract each other. only have no idea. So this will be our answer. Thank you very much.